Hello everyone. This video is to introduce you guys to section 5.4, which is on compound inequalities. Now, this section can be difficult for students because it involves a bit of logic. It's kind of hard to understand why we do the things we do in this section. So I'm going to try to give you some real life examples that are not based on math at all, and then show you how to do the math part. So with compound inequalities, what we're going to see in terms of a math problem is something like this. Graph x is greater than -5 and x is less than 2. So what this means is don't graph this separate and this separate. We actually want the solution where both of these are true. That's where we're going with this. Now, that might not make sense to you at this point, but suppose I make a statement like, I will only be happy, or sorry, not only be happy, but only eat dessert if I can have cake and ice cream. Well, when you read this statement, it's saying that I will only eat dessert if I can have both. Both of them must be true in order for me to eat dessert. That's kind of what's going to happen on the graph. So for example, if I only have cake, then I won't eat dessert. If I can only have ice cream, I won't eat dessert. But wherever I have cake and ice cream, then I will eat dessert. So birthday probablys are where it's at. So if we think about the graph of x is greater than -5 and x is less than 2. This is -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Well, x is greater than -5. I'm just going to highlight it. Is with an open circle here, and it's going to go to the right. Now, if I think about x is less than 2, well, that's also going to be an open circle, and that one's going to go to the left. So think of the yellow as the cake, and the pink or purple as the ice cream. Now, if I'm out here, where it's only yellow, that means I can only have cake. Well, I'm not going to be eating dessert. I won't be very happy then. Over here, with purple, I'm only thinking of ice cream. I don't want to have dessert then. So that's similar to what's going on in the inequalities. Over here, yes, it's true that x is greater than -5, but it's not less than 2. Over here, it's less than 2, but it's not greater than -5. So our answer has to be the place where both are true, and that's where you see both of them shaded. So my final answer would look a bit like this. I'll make this a little bit neater. If I put a line here, my answer has to be between -5 and 2. So open circle here, and my answer, my solution set, is in the middle. Because of the fact that the and, whenever you see the word and, we're going to graph where they're both true, the middle. Sometimes the and statement is called an intersection. The reason why it's called the intersection is because it's where both of them meet in the middle. And so now we're going to do another example. I want to graph the solution where x is greater than -1 and x is also less than or equal to 3. So I'm going to find -1, which is right here, open circle, and this is going to go to the right. A highlighter would probably be best for this. So now on this one, I'm going to graph x is less than or equal to 3. This one's going to be a closed circle, and it's going to go to the left. Now looking at these two graphs, do you see where they overlap? Not over here, not over here, but this kind of middle section, which I'll show you, between -1 and 3, but we're going to keep our open circle and keep our closed circle. So our final answer would have an open circle on -1, a closed circle on 3, and it would be in between the two. So it's the intersection, the middle of both of them. So now let's talk about where instead of the word and, we're going to use the word or. So the type of problem that you might see with this would be graph the solution of x is greater than 5 or x is less than or equal to 2. In this case, I'm kind of saying that I would be happy, in other words, the statement would be true if this happened or this happened. So for example, if I made the statement, I'll be happy if either the Seahawks or the Broncos make the Super Bowl. Well, both of them made the Super Bowl, so I'm happy either way. Now, if I made the statement, I'll be happy if the Broncos or the 49ers make it. Well, it's true that the 49ers did not make the Super Bowl, but the Broncos did. So I'm still happy, even though, yeah, it would have been nice if the 49ers made it, but I'm still happy overall. Because of the fact that one of them was satisfied, that answers it. So actually, it may be confusing, but when you see the word or, I want you to think of both. You're going to graph where both of these are true. Because if this is true, the answer is true. If this is true, the answer is true. And so sometimes this one is called the union because it's considered both graphs. So to actually finish out this problem, that was a terrible line. Or not a terrible line, but it's not straight. And zero, 1, 2, 3, 4, 5, 6. I could have spaced this better. X is greater than 5 would be from here with an open circle on to the right. X is less than or equal to 2. If I could just copy my same number line, would be here with a closed circle. I'm going to go to the left. Now, if you look at this graph, I would be satisfied if this is over here or if I'm over here. Well, what that means is I'm happy in both places. So my answer is going to have both of these components. So your answer number line would look like this. Again, assuming the same numbers in the same places. I would have this part of the graph from the top part, and I would have this part on the bottom. So sometimes students get confused as to why the or is the one that has both, and the and is the one that gets rid of stuff. But again, the reason why or has both of them is because I'm pleased with both. I'm a little bit more open-minded, and so I'll accept both. The and is kind of like a picky person. You kind of need both, and so that excludes a lot of things. So just to see another example, let's now graph x is greater than -2 or x is less than or equal to 7. Now I'm going to let you know that this one's going to be a little bit funny but hopefully you'll understand it after we do it. So x is greater than -2. Open circle, it's going to go to the right. X is less than or equal to 7. Close circle, left. So now we want to think about where, if I was in either of these, I would be satisfied. So what it's saying is if I'm over here, that's good. So that part of the graph is going to stay. And then if I'm less than or equal to 7, I'm also happy. Well, here's 7. Less than or equal to 7 is this way. Look what happens to your graph. No matter what number you have, anywhere on the number line, it satisfies this OR statement. It's kind of weird, but it's possible. If these overlap, you're covering all of the numbers, and so you're happy anywhere. The solution is all of this. And hopefully you guys remember that this would be all real numbers. And I'm writing in highlighter, which is not convenient for writing. We'll talk more about this kind of example on Monday, but if you're confused about that one, at least I hope you see that these two separate ones got joined together like this. That's why it's called the union, because you're joining together the two lines. So what I want you guys to try for homework is on page 306. I want you to do number 1, number 2, number 6, and number 7. So there's only 4 problems. You have a mix of odds and evens. Don't forget that the odd ones are in the back of the book, so you can check your answer. Have a great weekend.